All right, here's chapter 2.1 notes. Talk about conditional and biconditional statements. And talk about converse, positives, things like that. You'll see what we're talking about. To start off, we're going to talk about a conditional statement. A conditional statement is an if-then statement. If it is a cat, then it has 4 legs. It has to be logical. It has to start with if, and then the last part is then. The hypothesis is the first part, right there. If, the hypothesis, if it's a cat, then it has 4 legs. The then is the conclusion. So if means hypothesis, then starts the conclusion. The converse is where we switch. And I take both my hands and I actually switch them when I say converse. And it helps me see it in my brain and kinetically, kinesthetically. My body helps me remember when I switch my hands positions, I think of converse. So instead of the original statement is up here, if it's a cat, then it has 4 legs. We take that and we switch it. If it has 4 legs, then it is a cat. And that's what we talk about when we say converse. Now, if we talk about a negation, that means I'm taking whatever it was and I'm putting a not in there. So if it is not a cat, then it does not have 4 legs. And now a negation is only one or the other. I'm negating A or I'm negating B. I'm making the hypothesis a not, or I'm making the conclusion a not. So if it's not a cat, then it has 4 legs. Or if it's a cat, then it does not have 4 legs. That's negation. Inverse is where I make both of them negated. If it is not a cat, then it doesn't have 4 legs. And for this, I take both my hands and I flop them down and I negate both of them. If it's not a cat, then that's an inverse. These are vocabulary words. You need to memorize these so you can use them properly on a test. We talk about the contrapositive. This is like if the converse and the inverse had a baby, and it does both items. It's a converse and an inverse at the same time. So we switch their position and we negate them at the same time. So if it doesn't have 4 legs, then it isn't a cat. There's the negation, you see both of those, and you see that we switched their places. That's a contrapositive. So a contrapositive and the original conditional statement are logically equivalent. That means that if the original statement is true, then the contrapositive is guaranteed to also be true. And if the original statement is false, then the contrapositive is guaranteed also to be false. So if we look at this statement, 3 points are collinear if they lie on the same line. If I turn this into a conditional statement, then we say if 3 points lie on the same line, then they are collinear. And a lot of people get confused about how I rearrange that. This is one way to rearrange it. But you see how the if starts out the hypothesis. If they, well, they is a pronoun. We don't start with pronouns. We start with actual things. So we say if 3 points lie on the same line, then they are collinear. This may be a little bit different than what you see in your notes for your examples. Let me turn there so I can be following along. All I have is the homework right in front of me. All right, I can see here that it is the same that what you've got. So this is what should be in the first block right here. This is your conditional statement, okay? Right here. That is your first block. Now, it says next, it says to look for the hypothesis and the conclusion. Well, the hypothesis is the part after the if, and the conclusion is the part after the then. So there's my hypothesis. Let's go ahead and do that. My hypothesis is the first part, and my conclusion is the then part. So hypothesis, 3 points lie on the same line. Conclusion, they are the collinear. Next one is to write the converse, inverse, and contrapositive. Converse, take both your hands, hold them up by your head, and you switch their positions. So you cross your arms. That means switch. So I take both the statements, the blue and the purple, and I switch their places. If 3 points are collinear, then they lie on the same line. That's your converse. If I say inverse, that means not. So I take both hands and I flop them down, up and down, and I say they are inversed. If 3 points do not lie on a line, or lie on the same line, then they are not collinear. There's your inverse. Contrapositive is where we do both of these. We switch their places and we say not. So we take it and we say if 3 points are not collinear, then they do not lie on the same line. These are very similar to problems 7 and 8 in your homework. Turn there now and work on them if you'd like. Pause the video, come back, do whatever you want to do. But I'm going to keep going on. This isn't an English class, so why do we have to do this? It's wrong to do all this English in math class. In geometry, we use a lot of postulates and theorems, and they are written in if-then format. And a lot of times we use their converses or their contrapositives to help us prove other things. So if we talk right here, two lines are called perpendicular if they intersect to form right angles. All right, the abbreviation for perpendicular is an upside down T. We've talked about this in class before. So two lines are perpendicular if they form a right angle. There's some way to look at it. You've got the little shape here, that means perpendicular. You've got the upside down T. Now, if it's perpendicular to a plane, that's different. Perpendicular to a line is just 90 degrees. Perpendicular to a plane is perpendicular to every line in that plane that intersects it. So right here, this flagpole is perpendicular to the plane of the floor because it's going straight up out of the ground. And every line on the plane of the floor intersects it at 90 degrees. Okay? We go on with conditional statements. Here we go. This is your next example. We're going to cross it off of the notes because it's a little bit different. Mine says on the notes if an angle measures 90 degrees. Yours says if it's greater than 90 degrees. Regardless, we're going to follow the notes and say, is this statement true? If an angle measures 90 degrees, is it then an angle is a right angle? Is that true? Say, yeah, it's true. The converse, if an angle is a right angle, then the angle measures 90 degrees. Is that also true? Yes, it is. If both the original statement here and the converse here are both true, then we call it a biconditional statement right here, biconditional statement. When a conditional statement and its converse are both true, it's called biconditional. We rewrite these two statements into one big statement, combining them with if and only if between the hypothesis and the conclusion. Watch how this works. An angle is a right angle if and only if the angle measures 90 degrees. This if and only if means it can go both ways. And when I think about the word bi, I think of like a bicycle. The wheel on a bicycle can go forward or it can go backward. It can go both ways. And this statement can go forward like this. If an angle measures 90 degrees, then the angle is right angle. Or it can go backwards. If an angle is a right angle, then it angle measures 90 degrees. So since it can go both ways, we call it a biconditional statement. And we replace it with if and only if, also known as IFF. Capital I, capital F, but you'll see. All right, so here it is. If and only if equals IFF. They're the same thing. We can write it that way. This is just something that you'll need to know. If I give you a statement that says if and only if, you need to know that it's true both directions. And you're going to use that in your proofs. If it has 4 legs, then it is a cow. Okay, let's talk about what a counterexample is. A counterexample is something that is true for here, but false for the last part. So I think about this, I say, okay, if it has 4 legs, what has 4 legs? A cat, a dog, a giraffe. Are those things cows? No. So those are counterexamples to this if-then statement. So I could say, well, a cat has 4 legs, but it's not a cow. So thus proving this whole statement is false. We go on, we talk about counterexamples in 2.2. Again, here's example 2.2, but the numbers are off. But this is going to be like your examples in problem 1, 2, and 3 on your homework. So it'll be similar to what's in your homework, but not exactly. If I ask you to state if it's true, okay, write the converse, inverse, and contrapositive of the following true conditional statement. This one's true. If it's 99 degrees, then it's obtuse. The converse, switch it. If an angle is obtuse, then it is 99 degrees. Well, that's false. I can think of a really easy counterexample. An angle that's 100 degrees. Oh, hey, how you doing? Press record. Okay, so we're back to where we were talking about. And I'm looking for a counterexample to this, and I say an angle that measures 100 degrees, and that's my counterexample. All right, someone just came in my room, so I had to pause for the video. Sorry, I lost where I was at. Converse, is this a true statement? If an angle is obtuse, no. We find a counterexample, we say it's an angle of 100 degrees. It is obtuse, but it's not 99 degrees. So we can say it's false with a counterexample. All right, so next we talk about the inverse. If an angle is not 99 degrees, then it is not obtuse. Is this true or false? Again, false. I can think of if an angle is not 99 degrees, well, it's the same thing. An angle is 100 degrees. Is that not 99 degrees? Okay. Is that angle not obtuse? No, it's obtuse. A 100-degree angle is still obtuse. So this is a false statement, and we can do it. Now, contrapositive. If an angle is not obtuse, it is not 99 degrees. If an angle is not obtuse, okay, that means if it's not obtuse, that makes it either a straight angle, a 90-degree angle, or an acute angle. Okay, then it is not 99 degrees. Okay, is a straight angle 90 degrees? No. 90-degree angle? No. Acute angle? No. So this statement is true, because if it's not obtuse, oh, there's the bell, then it is not 99 degrees. I like it. Good to go. So right here we go on. Again, we talk about the original conditional statement and the contrapositive are logical equivalent. Means if one's true, then they're both true. I will work after school only if I have time. Are these biconditional? They go both ways. I will work after school if and only if I have time. Think about these ones on your own. Number 2, we're going to do number 2 together all the way throughout. If an angle is called a right angle, if and only if it measures 90 degrees. That's true. Let's work backwards. If an angle measures 90 degrees, then it's called a right angle. That is also true. So this is, in fact, a biconditional statement. Check mark. It works. Number 3, 2 segments are congruent if and only if they have the same length. 2 segments have the same length, then they are congruent. This also works. They are both biconditional statements. I'm going to go a little bit faster here, so feel free to pause and fill in the notes if you need to. Rewrite the biconditional statement as a conditional statement and its converse. So here it is. A triangle is a right triangle if and only if it has one right angle. Let's break this apart into 2 statements. If a triangle is a right triangle, then it has one right angle. Now the converse of this is if a triangle has one right angle, then it is a right triangle. We're taking a biconditional statement, if and only if, and we're turning it into 2 statements that are true both ways. Here's another one. Parallel lines are lines that have the same slope. If 2 lines are parallel, then they have the same slope. Converse. If 2 lines have the same slope, then they are parallel. This 2 lines comes from this plural right here. Parallel lines. They're actually plural, so we have to say 2 lines. Next one. If 2 lines are parallel, then they have the same slope. So are these statements true? What do you guys think? They're actually false. We have one situation where 2 lines have the same slope, but they aren't considered parallel. If those 2 lines happen to line up on top of each other, like this, then we call them coincident, and we'd say that they are not the same. All right. What criteria must be met for a conditional statement to be written as a biconditional? Then the original statement and the converse both have to be true. Take some time to write that into your notes. We're going on. Number 2, if a conditional statement how is a conditional statement written as biconditional? We would say hypothesis, if and only if, conclusion. Okay. We're actually going to skip the foldable, but I want you to go over the foldable right here. This is what this will look like when we're done making it. If it's a monster, then it's blue. Hypothesis, it's a monster. Conclusion, it's blue. Converse, if it's blue, then it's a monster. Inverse, if it's not a monster, then it's not blue. Contrapositive, if it isn't blue, then it isn't a monster. biconditional. It's a monster. If and only if it's blue. That's your foldable. All right, we're going to keep those. Here's some algebra examples. We need to write these in our notes correctly. But this is how you're going to solve for this problem. You're going to add 3 over. You're going to times both sides by 2. You're going to square both sides. You're going to add 6, and you're going to divide by 5. Hello! All right, so real fast, we got to finish this off. Let's see, I wasn't there. I was up here. Yeah, we talked about squaring, adding 6 divided by 5, division property of equality, just like those examples. Now, if I say if this, then that, that's deconstructing it. We start off with here as the given, and then becomes the proof. We got to prove that's true, and we got to show reasons for why, how, and we get there. We'll talk about that again later. Right now, let's go over here. You see, we've got the given part. That's the definition of angle bisector. We talk about the transitive property, and then we say subtraction of equality, and then we do subtraction property again, and we get to there. So that's, I'm just going quick through these. You guys can put these in your notes, and we're done. That was fast. Why does it seem so fast? Something must be wrong. Hope not. Oh well. There's 2.1. If you have questions, come see me. Thanks.